My name is Zach Chandler, and I'm going to start going through how amino groups combine together, and I'm going to show actual structures. And the ones I'm going to focus on are based off endorphins. So they have this model to it, which should be tyrosine, glycine, and phenylalanine. So what I'm going to do is combine these four structures with the models I have, and we're going to start with tyrosine. So this right here is what tyrosine looks like as a structure. The way I mark this is I have the chiral carbon in the center, and it's chiral because it's attached to different groups. So it's attached to the acid, the carboxylic acid, the amine group here, and then the R group that's attached, and additionally it also has a hydrogen. So this is a chiral amino acid, whereas the next two, which is going to be glycine here, since it has two hydrogens, then it is achiral, and that can be seen here in these. And these right here are the same exact molecule. So glycine and glycine, those two will go together in the center. And then the last one is going to be this one, phenylalanine. The main difference with this structure is it doesn't have a alcohol group off of the ring. That's the main thing about it. But once again, it does have a chiral carbon because it's attached to four different things. It has the carboxylic acid, the amine, and the R group off to the side of it. And now I'm going to show how these combine together. So the simplest example is probably looking at the two in the center. So for this bond to form, it's going to look as such. So what has to happen is on one atom where we have the carboxylic acid, we're going to remove an oxygen and a hydrogen, and those two are going to come off. And then what's going to happen is a hydrogen on the next group, the nitrogen, will come off. And you're going to form H2O with this molecule, and then these two are going to combine together. And notice too that these still have the double bonded oxygens, which can be seen in this image, probably the easiest. So right now the only parts we've combined is the centerpieces, and now I'm going to combine the last two. So once again on this side we have an amine, so we're going to remove a hydrogen and we're going to attach it to the OH from the carboxylic acid, and then we'll combine the two. Okay, so now our molecule has gotten larger. So now what we're looking at is this piece up here. And we still have one more piece to add to it. And as you see, this does get quite larger. So on the last one here, we're going to remove the OH, and it has to attach at the nitrogen. Okay, so the end product might be too big to see here, but the common thing that you see in endorphins and drugs that mimic the effects on the receptors is it has the tyrosine, glycine, and phenylalanine, and these four make up the part of the endorphin, which is probably best shown here. So as you can see, it's a really small chunk for the entire molecule. But this right here is what it actually looks at in a 3D model. So it's quite large structure. And hopefully that helps.